Welcome to E-Padasala. Myself Dr. V. Ramesh Babu from Kumarur College of Technology, Coimbatore, attached with Textile Department. Today we are going to discuss about finishing agents. Finishing agents is the agents which we are going to apply after dyeing or printing process to enhance some functional properties in the fabric or yarn. So in this finishing agents, today we are going to discuss three finishing agents. One is water softness and water repellent and optical brightness. So what is softener? Softeners have gained great importance in textile finishing. Almost no piece of textile leaves the production facility without being treated with softener. So the first sentence is giving full importance of softener, why it has been used in industry. This softening treatment is to give the textile to the desired handle, make further processing easy and improve the handling properties. So once whenever we are going to make dyeing or printing, whatever may be, and finally convert the garment that come to the customer going to feel the fabric whether it is good or bad by using hand. So in that case the handle, that softness, smoothness going to matter to the customer whether to decide buy or not. So for that case we are adding softener to the fabric to enhance this handle property like softness, smoothness, crispiness or something like that. The softener main purpose to improve the aesthetic property of textiles, not only handle property. Visually when going to look the garment, they are going to give some lustres and bright appearance and so on. So that's why it is very important to put the softener as a finishing agent to the fabric to enhance the aesthetic and handle property of the fabric. In most cases the duration of the effect is limited. It means that after several laundering the softness finish what we are giving now that will be washed off. So that still it is a problem, but nowadays people have developed so many advanced softness that going to withstand in fabric for so many laundering. So durability is high. So these are the types of softness: non-ionic softener, anionic softener, cationic surfactants, silicon based softeners, reactive softener, amorphotic softener, polyethylene based softener. Non-ionic softeners, generally this is based on ethers and polyglycol esters, oxyethylates products, paraffins and fats. So paraffins widely used. These softening agents are generally less efficient than anionic and cationic ones, but they withstand the effect of hard waters, acid and basic environment, and also in presence of cations and anions, therefore the normal fabric care conditions. So what it means they are less efficient than anionic cationic, even though that they can withstand the hardness of the water. If they suppose the water having so much salt content also, this kind of softener able to react with them and give good softening effect. Apart from this, the handle care fabric also well taken by this non-ionic softener. So these are advantages and disadvantages of non-ionic softener. Advantages: imparts bulkier, smooth handle, non-alloying and suitable for whites. So mainly we are applying the softener for this thing only. We have to get smooth handle and should be suitable for white. Most of the time we are going to make a bleached fabric, so it will be in the white color. So in that case the yellowing will be happen. To avoid that, you can use non-ionic softener that going to give better result. Does not change dye shade, compatible with OBA and resins. So it means that it will not affect the hue and tone of the dyes, and if you are going to apply the optical brightening agent and resin also, this will be compatible. That means they will not have any reaction on that and show the adverse effect. So disadvantages: less softness compared to CS, that is called cationic surfactants, less durability compared to CS, mechanical deposition by padding, maybe deteriorate wet dry crock fastness. So while we are applying all this softener through padding angle only, so this process going to have make poor rubbing fastness. Anionic softener are produced by the condensation of fatty acids. They have good characteristics as lubricating softening agents and give the fabric a full hand. They are unstable in hot water and acid environment. Anionic finish agents are negatively charged by ultrafiltric group. the cellulose acquires negative charge when wetted out and attracts the positive charge. So obviously positive and negative attraction only will happen in anionic and as well as cationic softener. Anionic softener are is stable at normal textile processing temperature and compatible with other components of dye and bleach agents. Can easily be washed and provide strong anti-static effect and good rewetting properties, oriented outward and surrounded by thick alteration. They are often used for special applications such as medical textiles or combination with anionic fluorescent brightening agents. Advantage and disadvantage of anionic softener. Advantages: good rewetting properties, that is needed for to improve the absorbance of the material. Good stability towards heat, so that is another advantage when we go for laundering in hot conditions. This softener is withstand for long time, less yellowing and good for lubricating lawns. Disadvantages: less softness compared to other softeners, limited durability to laundering, mechanical deposition by padding incompatible with resins. So here also we have to apply by using padding, and when you are going to treat with resin, there will be adverse effect on the fabric. Cationic softeners, usually they are ammonium salts, amino esters and amino amides. They are recommended for all type of fiber and can be also applied with exhaustion process in acidic environment. We have to maintain pH of 4 to 5. They are the best softening agents and are also called molecular velveting agents because they form bonds with the cationic groups on the surface of the fiber, generally with a negative electric potential. They can give some problem in the presence of large anions, and they can cause dye toning or reduction of fastness to light values in the presence of direct and reactive dyes. They also have high polluting charges as wastewater. These are some of the disadvantages of cationic softening agents. Advantages and disadvantages: impart soft, fluffy handle, durable to multiple washes, imparts anti-static properties, suitable by any method, compatible with resins. Disadvantages: more yellowing, not suitable for whites. Poor rewetting properties, may change dye shades, may deteriorate light fastness, not compatible with anionic. So compared to anionic, anionic give better result than cationic. Silicon based softener, commercially highly successful nowadays. People are using silicon like Resil and so many chemical companies manufacturing this softener. Silicons are macromolecule composed of polymer background of alternating silicon oxygen atom with organic groups attached to the silicon. Silicon softening capability comes from the silogen backbone's flexibility and its freedom of rotating along with SiO bonds. So the chemical structure, we can see that it is like branch structure, where because of this branch the things other stuffs cannot deposit on the fabric, so always we go get the smooth and lesser properties of the fabric. They are insoluble in water and therefore must be applied on fabric after emulsification, dissolution in organic solvents. They feature quite good fastness to washing. They create a lubricating and moderately waterproof film on the surface of the given fabric, a silky hand. That's why I told the waterproof effect. So because of that, unwanted things of foreign matter cannot be accumulated on the fabric. So always the fabric look very clean and aesthetic and lesser and soft and smooth. They provide very special unique hand, high lubricity, good sewability, elastic resilience, crease recovery, abrasion resistance and tear strength. These properties are very much needed for when the fabric is converted into garment, where the sewing process will not create any problem by sewing. There is so good temperature stability and durability with high degree of performance for those products that form cross-linked films and range of products from hydrophobic to hydrophilic. So the cross-linked links are very specific nature of the silicon based softener. That's why we are getting so much enhanced property what we have discussed earlier. So other softeners, they are reactive softener. N-methyl derivatives of superior fatty amides are uses urea component replaced with fatty acid. The products are to be cross-linked and provide permanent softness and water repellency. Amorphotic softeners, typical properties are good softening effect, low performance to washing and high anti-static effect. They have fewer ecological problems than similar cationic products. Examples are betaine and the amylene oxide type. Then polyethylene based softener. Polyethylene can be modified by air oxidation in the melt and high pressure to add hydrophobic character, mainly carboxylic acid group. Emulsification is the presence of alkali provides higher quality and more stable products. They are stable to extreme pH condition and heat and normal textile processing condition and compatible with resin and fluorescent brightening agents. They are very strong in improving properties like tensile strength, tearing strength, sewability, abrasion resistance, and so on. So this is also commercially highly used by the industry. So mechanism of softener, very simple mechanism. Softeners provide their main effects on the surface of the fabric. Small softener molecules in addition penetrate the fiber and provide an internal plasticization of fiber forming polymer by reducing the glass transition temperature. Depending on the ionic nature of the softener molecule, the relative hydrophobicity of the fiber surface, cationic softener orient themselves with their positively charged ends towards the partial negative charged fabric. So here cationic softener is positive and fabric is negative. Obviously the both going to attract. In anionic softener this will be vice versa. So application methods. Softeners are mostly applied by forced application like padding and spraying. Form relatively concentrated solution which transfer all the liquor onto the fabric. In batch processing, softeners are often applied by adjacent form diluted bath on machines such as jet, overflow or veins. Here the adjacent rate is relevant to the ecological consideration of wastewater loads. Application by foam applicated by spray technique are common in the case of made up garments. So after making the garment we can go for dyeing and finishing. In that case we can go for foam application. That depends upon the substrate and the feasibility of adapting either of the process. Then second finishing agent what we are going to discuss is water repellency. Water repellency is more difficult to define because various static and dynamic tests are used to measure the water repellency. Generally speaking, water repellency fabric are those which resist being wetted by water drops with roll of the fabric. A fabric resistance water will depend on the nature of the fiber, surface, the porosity of the fabric and dynamic force behind the impacting water spray. The condition of the test must be stated when specifying water repellency. Water repellency fabric have open pores and permeable to air and water vapor. Water repellent fabric will permit the passage of liquid water once hydrostatic pressure is high enough. See, there are two types of fabric. One is water repellent fabric and waterproof fabric. Waterproof is entirely going to block everything. They will not even allow air or something like that. In water repellent fabric only liquid will not be allowed and air and other things will be allowed, so that going to give the comfort to the wearer. So these are the most successful used agents, water repellent agents. One is hydrocarbon hydrophobe based agents. Second, here also the silicon based water repellent and fluorochemicals. In hydrocarbon hydrophobes, paraffin wax, it is commercially nowadays people are using the oldest and most economical way to make fabric water repellent. It is a coat with paraffin wax. The paraffin wax melts and wicks into the fabric when the fabric is heated. This will cause most of the fiber to be covered with a thin layer of wax, especially those they are exposed to water and fabric will have excellent water repellent properties. The major disadvantage of wax water repellent is poor durability. After washing, it will goes off. It also removed by laundering process. A typical wax emulsion consists of paraffin wax as the hydrophobe and emulsifying agents and emulsifying stabilizer and aluminum and zirconium salt to deactivate the emulsifying agent when the fabric is heated. The stability of wax dispersion and the durability of wax finish have been increased by formulating polymers such as polyvinyl alcohol, polyethylene and copolymers of stearyl acetate, acrylic or metallic acids. So this is a typical example of a structure of paraffin repellents. We can see that typically the products emulsified and contain aluminum, zincornium salts or fatty acids. This material increase the finish addition to the polar surface. See, you can see the structure where there will be base molecules, that is fiber molecules. Above that there will be branched wax molecules. So that obviously going to avoid the water entering into the fabric. Fiber reactive hydrophobes, where nowadays people are using N-methyl-stearamide in an effort to improve the durability. Of earlier case discussed that paraffin wax having poor durability. After repeated laundering, the wax is going to come out of the fabric. To avoid that, people are nowadays using N-methyl-stearamide. It's a water repellent. Several approaches incorporate reactive groups have found commercial success. The simplest of these N-methyl-stearamide reacts with formaldehyde to form N-methylol adduct. This adduct is a water dispersible and either will react on curing with cellulose. Another component, pyridine components, this famously used as a water repellent agent. The variation of N-methyl-stearamide is the pyramid type water repellent. These were once very popular and used extensively as reactive type water repellent finishes. Toxicological consideration had been curtailed the use of pyridine type water repellents. Pyridine type water repellent co-applied with fluorochemical repellents resulted good. See, we are combining pyridine and fluorochemical, so that going to enhance the water repellent efficiency of the fabric. The finish was durable to field laundry producers and named Corapil by its inventor. It means that after frequent laundering also the finish will be stable on the fabric. Resin formers. The multiple reactive sites on methyl melamines can be utilized for making resin forming water repellents. This is another one type of water repellent. Silicons. Softener, we are using silicon. Same water repellent also we are using silicon. These products are stable to washing in water 60 degree with solvent. That is one of the major advantage of using silicon. They can be used to treat uniform, raincoats and sportswear. These products are very popular since they are allow excellent waterproofing properties, optimum solidity and enhanced combined pleasant soft hand. They are suitable for applied on all types of fibers. The high water repellent effect on soft hand are due to the orientation towards the outer surface of the methyl groups. See, a simple application, silicon applied fabric either form an organic or form water or an emulsion. When cationic emulsifier is used to make emulsion, the finish may be applied by adjusting, since the negative fiber surface charges attract positively charged particles. Generally, our silicon water repellent are co-applied with durable press finish. Durable press finish nothing but when we need pant with pleat. So that time we are going to apply durable press, so that pleat will be long lasting. So in that case, we can add silicon with that, so that going to give enhanced performance of water repellency. The fabric is resistant to water borne stains such as coffee and soft drink. That is the one major advantage of using silicon water repellents. Here also you can see the structure of silicon water repellent. So all the structure, obviously there should be a branches, cross linkings. This cross linking in branches only avoid the water enter into the fabric. Silicon water repellents advantage and disadvantage. It is durable to washing and dry cleaning. Durability is brought about the formation of sheet of finish around the fiber. If the sheet cracks, durability lost. Absorption of the hydrophilic substance found in dry cleaning and laundering products also impair water repellency. Silicons are more durable than wax repellent, but less durable in fluorochemical. See, compared to paraffin wax, silicon is better, and compared to fluorochemical, it is not that much better. Silicons are more expensive than wax repellent. Silicon finish resist water, borne stains, and as earlier discussed, coffee or any other thing, it will be resist in forming on the fabric. Fluorochemicals, the oil and water repellent feature of fluorochemical polymers lead to finishes applicable to two consumer product area: durable rainwear fabric and stain and soil resistant products. For rainwear products, superior durability to repeated laundering and recleaning. So this is mainly used for raincoats. For stain and soil resistance, the plus feature are fluorochemical will to prevent oil from agents. They can only avoid the water penetration. Here by using fluorochemical, even you can avoid the oil penetrating also. Waterborne stains can be held out by silicon water repellent, however the oil based stains can be repelled by the fluorochemicals. For textiles that cannot be laundered, upholstery fabric, carpets, where you can use fluorochemical. For fabric that can be laundered or dry cleaned, stain removal is more important than the stain prevention. This is a structure of fluorocarbon based repellents. Here also you can see the different brands effects. This branch effect going to avoid water and oil penetration into the fabric. The final agent what we are going to use, optical brightness. Numerous materials, especially textile, both classical cotton, wool, linen, silk and synthetic polymer, polyester, polyacrylate are not completely white, and efforts have been made since ancient times to free from the reliant tinges. See, whenever you are going to make a fabric, we have to get the white shade or brilliant shades. It is not happening means the customer aesthetic feel will be goes off and the people not buy. For to enhance the whiteness of the fabric, we are applying optical brightener agents. Bleaching in the sun, bluing and later chemical bleaching of textile and other material increase the brightness of the products and eliminated certain extent of yellowish. After prolonged sunlight, the fabric obviously tend to be yellowish. That yellowish effect will be give poor look to the fabric. So to avoid that, we are using optical brightening agents. When optical brightening first came up, they were regarded as bleaching auxiliaries, which enabled short or milder bleach when used very small quantity, approximately 0.001 to 0.05%. They were so called optical bleaching agents. Classification, there are two types of classification. One is direct brightness and dispersed brightness. In direct optical brightness agent are predominantly water soluble substance used for brightening of natural fiber and occasionally for synthetic material. Dispersed optical brightening is obviously insoluble and will be used for mostly used for synthetic like man-made fabric. They are used for synthetic materials such as polyester, polymer, acetate and sometimes on paper too. Classification of optical brightening agents from the chemical. See, there we can classify into two types. One is based on the application method, another is chemical agents. From the chemical point of view, they are classified according to the chemical structure. The chemical optical brightening agents classified into derivatives of tilbane, coumarin, 1,3 diphenyl pyrazine, derivatives of naphthalene dicarboxylic acid, derivatives of heterocyclic dicarboxylic acid, derivatives of cinnamic acids. So this is based on the chemical classification. So nowadays people are using mostly fluorescent optical brightening agent. The OBA are mostly widely in textile and paper. The optical brightening effect is obtained in addition to of light, which means that the amount of light reflected by fluorescent brightening agents are called optical brightener. See here, the high energy radiation in the ultraviolet to violet range is 330 nanometer to 380 nanometer. On the other part, the molecular that emit low energy radiation, that is a blue range, it is visible at 400 nanometer to 450, which yields to counteracting of yellowing appearance. Anionic will be adjust on cotton, wool and silk. Cationic will be adjust on acrylic, certain polyester, and non-anionic will be on adjust on all synthetics. In textile where you are using, it should have good solubility, should have its own color and good substantivity of textile structure and OBA application. OBA should have good light as well as wet washness property. Its rate of strike on substrate, build up and exhaustion properties, requires of electrolytes and sensitivity towards different exhausting agents, effect of temperature on exhaustion and build up properties. Application of pH range and sensitivity towards change in pH, effect of water hardness, should be a good leveling and penetrating properties, should not decompose to color products on exposure to atmospheric conditions, and should have absorb light in visible region. It is compatible, stable with other finishing chemicals, auxiliaries and with heat and temperature. It should be stable and fast to common additive, oxidative and reducing bleaching chemicals and bleaching systems. So in this finishing agents, we have discussed three finishing agents. One is water softness, second one is the water repellent agents, and third one is optical brightening agents. The main purpose of applying the finishing agents to enhance the handle and aesthetic look of the fabric. So water softness is used to give the softening effect on the fabric, where you can enhance the smoothness, lustres and handle of the fabric, whereas we have discussed so many softening agents like non-ionic, cationic and silicons, fluorochemicals, such. In water repellent, it is applied to the fabric to avoid the penetration of water or oil into the fabric. It is a functional finish, where we have discussed the method of application and different types of water repellent like fluorochemicals, silicons and hydrocarbons. And finally, discussed optical brightening agents, shortly called OBA. The purpose of giving optical brightening agents to give the white look to the fabric and to avoid the yellowish in the fabric, where we are used commercially using fluorescent optical brightening agents. That is very much enhance the property of brightness as well as reduce the yellowiness and increase the fastness of the fabric.